let's do some more divisibility problems involving variables. So this one says if x and y are positive integers, is x over y an integer? So is x over y equal to an integer? So just like in the last question, where they gave us statements talking about 5x and 6x, and I'm always thinking to myself, well, what is that telling me about x? In this case, I am thinking, I want to find out what each of the statements is telling me about x over y. So how else can we think about this question? Is x over y equal to an integer, or is x a multiple of y? Is y a factor of x? Does x contain a y? Those are all saying the same thing. Statement 1. X is divisible by 3y. So that is telling me x over 3y is equal to an integer. So I want to know what this is telling me about x over y. So I can, this x up here is really just 1x. So I can sort of pull out a 1/3 to isolate my x over y. So saying 1/3 times x over y is equal to an integer. So let's think about what this is telling me about x over y. And I think people get a little bit confused here, or they find it hard to find out, think about the properties of x over y because it is a fraction as opposed to just a single variable. So let's say we just had something like this. And 1/3 times a is equal to an integer. Well, what would that mean about a? That would mean a would have to contain a 3 so that it could cancel out this 3 here in the denominator. Because the only way to get an integer is by getting rid of this denominator here. So 1/3 times 3, for example, that would work. 1/3 times 6, that would work because that cancels the denominator and leaves you with just a 2 on the top. But 1/3 times 5 would not work because that leads to 5/3. You cannot get rid of the denominator. So to cancel out our denominator here, a has to be a multiple of 3. Now, what we're doing here is no different. Just we happen to be saying a is equal to x over y. So this is really telling us x over y is a multiple of 3. Now, all multiples of 3 are integers, so it cannot be any integer, but x over y can only be integers. So this statement is sufficient. This gets at sort of talking about what could be true about a variable or a variable expression versus what must be true. So even though x over y cannot be any integer, it can only be multiples of 3, the only values that it could be are integers, which is what makes statement 1 sufficient. Let's compare that to statement 2. This is where I think people are more likely to get tripped up. So this says 6x is divisible by y. So this means 6x over y is an integer. So if we isolate our x over y, 6 times x over y equal to an integer. So at this point, what most people say is, well, 6 times any integer is going to be equal to an integer. So x over y can be any integer. Therefore, this is sufficient. And they would say the answer is D. But that is not true. Because just because x over y could be any integer, what we want to know is, does x over y have to be an integer? So once you determine that x over y could be any integer, or should really, once you determine x over y can be any integer, what you should be saying after that is, well, could it also be a non-integer? And it definitely can. So x over y can be anything as long as any fraction, as long as the denominator cancels out with this 6. So 6 times 1/2, for example, would work. 6 times 1/3 would work. Anything with a denominator involving a 6 would work. So 6 times 5, 6. 6 times 7, 6. These would all result in an integer. And so the fact that once you determine, x over y could be 2, which gives you 6 times 2 is 12. So x over y could be an integer. Then you should not be saying, x over y could be any integer. That's not really helpful. Once you determine it could be one integer, you should be saying it could also be a non-integer. That is how you prove insufficiency. And so this is really what I'm talking about when I say people get tripped up with what could be true versus what necessarily must be true. They're asking what necessarily must be true about x over y in this question. So even though statement 1 is the one that is sufficient, you actually have less integer possibilities for x over y, because this can only be multiples of 3. In statement 2, x over y could be any integer, but it could also be a non-integer, which is what makes it insufficient. And so x over y could be 1/6, for example. Once you have both of these as possibilities, statement 2 becomes insufficient, and our answer is just A.